Hi, Tantan.
Good afternoon, Taniel.
Good afternoon, Miss.
So, Taniel,
Yes, yes, Miss.
what's next after this exam? What's next?
University, hopefully.
Look, you'll get there. You'll get there. What area of study?
Forensic science.
Oh, pardon me. Wow, nice. That's nice. I remember when I was younger, I wanted to do that. Yeah. But I was only inspired by CSI and those.
Yeah, that's why. Criminal Minds and stuff
Yes,
like that.
yes. I used to love it, but I keep on imagining it, that field in Jamaica. So you know that although you're going to be doing it, you'll not be, probably you'll learn and come back to Jamaica. Hi, Aniki, how are you?
Hello, Miss. I'm okay.
Nice. So we're not going to delay for long. We're going to start in the next 3 minutes. So the early birds will be catching the most worms. So Aniki, same question for you. What's next after this exam?
University.
To study what?
Forensic.
Eh? So this cohort is all forensic?
No, Miss.
Oh,
Some are medicine.
okay, okay.
And veterinary science. And those stuff.
Okay.
I mean, them want come investigate, man. Make them stay.
And here comes Natty B.
Yes, yes, sir.
Hey,
Wow.
Tantan, you're supposed to be on my side. You know, this is the third night I'm telling you the same thing. You're supposed to be on my side.
You want to investigate? That's nice.
Uh-huh. Proud of you. Continue working hard, guys. You'll get there.
Yes. All
Matter of
right.
fact, question. Before you go, miss, if not forensic, what's your second option? Okay, I guess they're gone.
No, not sure, sir.
You need to have that. You need to have a backup plan in place here. Very important.
Like criminal justice.
Yeah, they're under the same category, so
Yeah.
So what was that, Aniki?
Criminal justice.
Or criminal justice? Okay, all right, cool. Congrats. You guys will make it, man. Keep up the good work. All right, miss, you can take over, miss.
Sure. So thank you very much. And Natalie, Donaldson, and Monisha, what we were talking about just now, we were just getting a feel as to what's next. After this exam, what is it? What's the next step for you guys? And we were just saying, Aniki Anthony wants to go into forensic. What is your option? What is it that you're thinking about doing? What course of specialization, and always have a backup plan? What's next, right? Always keep that in the forefront as to when you're doing this course. So today is going to be very much accelerated. We're not going to be waiting long. And just giving you a chance to share using 1 minute, Natalie. What is your option after this class? What is it that you're going to be doing? So after this exam, what is it that you hope to do? Monisha, do you want to share?
Miss Pediatrician.
Pediatrician, okay. That's nice. So when you open your practice, you can let us know, okay? The person
Yes.
charging their families and so forth, yeah. All right. So probably Natalie not able to participate at this moment. We're gonna go into our lesson. Not gonna be long. I'm gonna give Sir maximum time possible. So this week you were given assignments. Sir given some assignments. Have you completed those assignments? So this is what Sir had asked us to do, right? So based on the time frame within which we have to work with, and then the deliverables that you as a team has to deliver for examination. We're going to go through this quickly, okay? So let's hear the answer. What did you get for question 5? Let me pull up my information here. And before we start, sorry, let us go back to that sentence per, right? Any volunteer? A quick sentence per or short?
Or thank you. Okay.
Go ahead.
Or thank you for another day. Thank you for watching over us and keeping us safe. Amen.
Amen. Amen. Thank you very much. All right, so question number 5. Has anyone tried that one? What did you
Yes,
get for
miss.
your
Yes,
answer?
miss.
Yes, miss.
Nice.
Miss for number 5?
Mhm.
Miss, I got 5.
5.
You got 5.
Yes,
Anyone
miss.
here did not get 5?
5, miss.
Anyone here did not get 5? Okay, so everyone here got 5. Very nice. Very nice. What about number 4? 4B.
Seven.
7.
7.
You got 7.
Miss, I did not get an answer.
Is undefined.
Undefined.
What? Who said they did not get an answer?
Well, miss, I never mean like that.
What you mean? I want to know
Miss,
what you
no,
mean.
miss, I know what I mean.
No, sir, I don't know. I'm not coming in exam with you, Natalie. I ain't coming in exam with you.
Miss,
So
undefined.
undefined.
Miss, yes, miss.
All right. Can somebody walk me through question 4B? Let me see if, since question 4B is where we're having a difference. So the person who said that they got 7, what was the denominator?
0.
0.
Right. So how come they're telling me 7? Is that the correct answer?
Someone says right undefined.
Right, but you can't tell me. Well, let me use the correct phrase. If you say 7, I'm taking it that it's the 7 whole number, 7 real that number.
Oh, miss, I realized that I didn't calculate it properly.
Okay. All right. So we're all on the same page, right? One last question. What about 4A?
5, miss.
5.
5.
Yes, miss, 5.
Who did not get 5? Show of hand. Okay. Let me call on Miss Parker. What did you get for?
5, miss. The 5.
You got 5. You shout out quick. You don't want to answer anything else. All right. That's nice, Parker. Very nice. All right. So let's look at the piecewise function. Sir sent out the document, okay? Sir sent out the document with many examples. Did you get a chance to look at it?
Yes, miss.
And worked any?
Yes, miss.
All right. Anyone else? Let's work a question from the piecewise and then over to Sir. This is because we are at a stage where we need to move faster and smarter so that you're exposed to all the requirements for exam, okay? I'm not throwing you out. I am actually working with you so that Sir can get in as much information shared with you. All right, so that, is there anyone having an issue showing the discontinuity of a function before I move on to the piecewise? Everybody has factorization practicing, or would you want me to work on one of the questions from the exam, from the assignment Sir has given?
Work one, miss.
Who says work one? Shante?
No, miss, it wasn't me.
Okay, who says work one?
And
Aniki, which one is it that you did not do? Aniki,
yes, miss.
which one you did not do? We have 1 to 5. Which one you did not do? Question 1,
Yes, miss.
that was it?
No.
Repeat that.
Miss, I said no.
So which question you did not do?
And 5.
Question 5. Okay, so we are uncertain as to how we got the, what was the answer? 5? 5, right?
Yes.
All right. Who did? John Mark, you did question 5. Can you guide me through? Let's go back up to question 5. Guide me through question 5.
Miss, I didn't get to do question 5. I didn't.
I thought everybody said they did question 5.
Miss, I
All
read
right.
in after. Yeah, look at that one.
All right,
So I
let's
wasn't
start
here when
question 5.
you.
That's fine. This is the assignment we're dealing with, John Mark. Sir gave the assignment last week. All right, so we're just going to do question 5 from this section and move on. All right, so let's see all my writing skills go on this platform. All right, so what's the first step here? Who's a volunteer guiding me through this question?
Which one, miss?
Question 5.
Substitute the x's with -5.
So we're saying, let me select here. Salim. Guys, don't laugh after my writing now, okay? X tends to -5, right? X tends to -5. Let's see what is happening to my arrow here. Okay. I don't know why that is circling and pushing it out. So let's go -3. And what you were saying, -5? Am I on the right track?
Yes, miss. Use the I factorize.
Yes, miss.
Okay. What is happening here? It was eating off my work. Thing is eating. All right, let's talk about it. Let's move quicker. So we're substituting -5. What's the answer when we substitute -5 into the
0
limit.
over 0. Indeterminate.
Indeterminate. John Mark and Aniki, did you get indeterminate?
Yes, miss.
Yes, miss.
So you didn't want me to work it out, man? Getting indeterminate, what's the next step? What
Instead of factorize the numerator, miss.
factorize the numerator? Okay. And what question do you ask when you know that you're going to factorize the numerator? What question do you ask?
What two numbers when multiplied? 7. Oh, it's never mind, miss. Let's see what I'm gonna. That is 15 or 5. Miss, all along, I never realized to say negative.
You didn't realize.
Yes, so that be positive 75. I will
Okay.
put us potentially negative 75. So never mind.
Okay, that's Aniki. John Mark, where are you? What's the question we're asking?
What two number when you add give you 20 and multiply give you 25? Negative 25. Negative 20.
Try again. What about the coefficient of x squared? What do you do with that?
Do,
What do you do with this? Right here. What do you do with the -3 when we're factorizing? Can somebody read?
hold on, miss.
Okay. Turn it off. Do not let it rotate, please. Ready for me now, John Mark?
Yes, I don't remember.
All right, so what's the question that you're asking at this point when you know that you're going to factorize and you're faced with -3x? Well, let me say it correctly, not -3x, -3x squared minus 20x minus 25. What's the first question you're asking? You're right here.
What two numbers when multiplied give 75, but when added give 20?
Gives
Negative 20.
-20. Right. So what two numbers are these, John Mark?
It's not that, miss.
I did not hear.
But when you add, gives you 20 and multiply, 25.
No, okay. I thought you said, sorry about that if I misinterpret. I thought you said what two numbers when you multiply gives you 25. So it's not 25 we're looking for. Or is it that you had said 75? 75? All right, I'll take it that you said 75. Positive 70. Okay, John Mark, you're a bit noisy there. So I'll take it that we're saying positive 75. So when we multiply the two numbers, which is the coefficient of x squared and the constant, the 25, so it's -3 times -25, giving you positive 75. And when you add those two numbers, you will get -20. What are those two numbers?
-15 and -5.
Thank you. So what would be the factors?
Miss negative 15 and negative 5x. Negative 15x and negative 5x.
Nice. So what would be in the factors of this? The
X plus
negative
5.
3x plus 5,
Was that said x plus 5?
x plus 5, and what?
Negative 3x minus 5.
All right. The writing not working out for me. Camera.
Just jump the step then.
Can you hear?
Yes, miss?
You're saying something?
Mr. say negative 3x minus. Mr. say jump the steps, miss. That's why I wasn't understanding what you were doing.
Okay. All right. I'll revisit the step for you. Okay.
No, miss, it's okay, miss, because that this is what I did, the factorization route.
Okay. All right. Sorry about that.
Oh,
So
so Miss, what I did was to multiply the negative 3 by the negative 25, and then you find what two numbers I multiply to get 75.
and add to give you
And add to get 20, negative 20.
negative 20. And we say those numbers are
Negative 15 and negative 5.
right, negative 15 and negative 5. Right. And now we're saying after you have the two numbers now, and we're factorizing, right? So we're now at the step where we have the two set of factors. What are those two set of factors? The brackets, the two brackets.
Miss negative 3x.
You want me to work it out from the finding the two numbers?
No, miss.
Okay. So what are the factors now? The two factors which are on top, forming the numerator.
X plus 5.
X plus 5 and
Negative 3x minus 5.
is everyone with us?
Yes, miss.
Yes, miss.
Miss, what are you doing, Miss?
Who is that? Chanel?
Yes, Miss. What
You're
question is?
number 5.
You did all the questions already?
We confirmed the answers.
Oh, okay.
So did you get a chance to work number 5, Chanel?
Yes, Miss.
What's your answer? What's the solution?
Miss, I got undefined as my answer.
Okay. Okay. I need to ensure that everybody is getting the same thing here. So let me try again at this writing. Let me try again at this writing. Mhm. Right, so let's continue, guys. So we have the factors here. Did you reach this far, Chanel?
Miss, I didn't do anything like that. So maybe that's why I'm not getting the same answer as everybody else.
Okay, all right. All right, let's describe and then you'll catch up, okay? Gonna do a short description and then you'll catch up. The first question, what we did first was to substitute the -5 into the limit. And what answer did you get when you substitute -5 into the limit? Chanel, speak, please. We're moving quickly today, okay?
What was the
Yes.
question?
When you substitute -5 into the limit, -3x squared, -3x squared minus 20x minus 25, all over 2x plus 10. What did you get? What's the answer you got?
I mean,
Okay, that sounds like you did not attempt the question. So what's the answer? Let's share the answer with Chanel.
I attempted the question, but how you guys are doing it, I didn't do it like that. So that's why I'm not gonna have what I
That's
have. I
fine.
attempted it.
That's fine. So what's the first answer that you got, Chanel? When you say, so 3 minus 3, it's not allowing me to type. So -3 I'm not sure what is happening with my device. It is deleting what it wants to. I'm sure in my practice session, it did not behave like that. Okay.
I just realized that I did something wrong, so that's why I got this answer.
What did you do wrong?
I didn't do the full subtraction and addition of the top number, so that's why I didn't get the 0 at the top and 0 at bottom.
Okay. And this works out to be 0 over 0. Is that correct?
Yes, miss.
Right. So now we're factorizing the top part, the numerator. So what two numbers when you use minus -3 times -25 minus 25, when you multiply it, it gets +75, but when you add it, you get -20. What are those two numbers? So someone had said -15 and -5. Correct so far?
Yes, miss.
Down too far. Right. Let's go. All right, so what's the next step here? What's the next step here? Grouping. We're factoring on -3x. And we're leave with x plus 5, right? So we know that we're going to get x plus 5 over here. What would come here?
-5.
-5. Hence, we are at this stage. Right, Chanel?
Yes, miss.
Okay, noted for Natalia. Right, so we can also factorize the denominator, or let's go. Is it factorized, or we can factor out 2, can we?
Yes, Miss.
Right. X plus 5 minus 3x minus 5. With this writing, I'm sure I'll get filed in the next hour, right? What would be the amount here? So what are we canceling?
X plus 5.
X plus 5.
And when we work out what we're left with, what are we left with?
Minus 3x minus 5 over 2 over x over 2.
Over 2. And when you substitute the minus 5 into this limit, so remember we're working out limit x tends to minus 5. What's the answer you get? So minus 3,
5.
right? Because the numerator will work out to be what? Minus 3 times minus 5 is 15. 15 minus 5 over 2. So this is equals to 10 over 2. Chanel, are we on the same page now?
Yes, Miss.
Okay, nice. And John Mark, haven't forgotten you.
No, not, you don't forget. I'm following.
You're following. Okay, nice. So let's do a piecewise question, and then that is it. Sir is coming on quickly, just as an example, right? Have you, let's see if I can pull up Sir's document. Let me see if I have it saved here. These are good notes for you to read based on the time and the plan, but given, how do you prove that a function is discontinuous? What would you say?
You see, equate the denominator to 0.
Equated to 0. We were just talking about continuity, and we continue with it, right? What would you, the denominator to be equal to 0? Or what would you refer to that as? Undefined?
Yes, miss.
Right. So can we work out this question? Did we attempt this question that Sir gave? This is the example we're going to be working out for the piecewise. What was the response? What was the solution you got? Anyone? Anyone attempted the question Sir gave?
Yes, miss.
And
I got
example 3.
discontinuous.
Which one is discontinuous?
The first one, x minus 2. X equal negative 2. And the next one is continuous.
At x equal
X
2.
equal 2.
Everyone is in agreement?
Yes, Miss.
Who is not in agreement? So who has a little challenge, did not get the same response as John Mark with the piecewise? Okay, so everyone, all right, everybody's okay. All right, so
So they just substitute the x's to see if they equal to 0.
this is brilliant child speaking. Aniki, so because you get it doesn't mean that everybody else get it. That's good, Aniki.
Well, it's a question I'm asking me.
It's a question. So how do you know? How do you know which one to substitute it in? How do you know? You tell me.
Mr. Jesus work until you find elimination.
Elimination. We have three. What would it? Three functions here, right? How do you know which one to put it in? When you say continuous at x equal -2, which one of these speaks to x equal -2? Which one of these functions would capture -2?
The first one and the second one.
And the second one. But what question are you asking there? The left-hand side or the to the right-hand side? Are you going to the left? This function goes.
First one is to the left and the second one is to the right.
Right. And so -x, we're capturing that one. So Aniki, would you have used -2 x squared minus 5? Why not using that one?
Repeat, miss?
When you're proving to the left of the limit x tends to -2 to the left, when you're finding the response to say if it extends to the left of that limit, right? Why not use x greater than -2 and less than or equal to 2? Why wouldn't you use the second function?
Second function, which is 2.
Yes, to say that when you're testing to see to the left of x tends to -2, right? Let me see if when you're having this, right?
Yes.
Which function would you use since we're going to the left?
Um, 3x plus 7.
Why? Can somebody share why you're using 3x plus 7? John Mark, why did you use 3x plus 7?
Because x is to the left of -2, and as it -2 is to the left of x.
Right, and that function alone, that it is only that function there that would cover to the left of -2, right?
Yes, miss.
So In the other option now, where the limit x tends to -2, but to the right of -2, which function did you use there?
Yeah. X squared minus 5.
Aniki, did you?
minus 5.
Thank you very much, John Mark. Aniki, did you use that function?
What did he say? X squared what?
-5. Did you use that function as a second to prove, to say that it is continuous or discontinuous at x equal -2, -2?
Yes, yes.
So why did, that's what I'm trying to get out of it. Why did you choose those two functions? Why would now you choose when when you're evaluating the limit, x tends to -2 to the right of -2? Why did you use x squared -5?
That is to the right.
It's to the right, but what in relation to right here, the range for the x? This is the only, see?
Oh,
It's the
maybe
only,
that's the only one it could fit in. To
right, because that is the only, the range that fits into that -2, to the right of -2 fits into. So yes, John Mark, we're agreeing with you to say that yes, it is discontinuous at x equal -2 and continuous at x equals 2. Anyone not in, is there anyone not in agreement with the response? Or anyone not seeing it? Or do you want me to continue working it out? But I think we're good and we're ready for sir, right? So we're reminded of the piecewise, how we're doing it. We evaluate the function and see where in the limits the x values would lie, which of these functions it will lie within. And then we use that to evaluate. Is it to the left and to the right? Are they the same? Do they equal to the same? If not, it is discontinuous as at limit x tends to -2, right? I'll share with you this document and the working. I'll type out the working. So I'll get some more practice with my writing and type out the working and send it to you. But good job, John Mark. So we are ready for sir, right? Or would you like to do another question?
Next question.
A next question, would like to discuss another question? I think we're ready for sir.
Yes, Miss, ready.
Mr. Shand? Yes, we're ready. We have a lot to accomplish tonight.
I'm here. Thank you, Miss. Got disconnected for a portion of the class, but thank you.
You're welcome.
Thank you guys for coming on. John Mark.
Yes, sir.
I've been fighting, because you have the potential, boy. But you're joking, you're lazy. But guess what? I like how you're turning out for the last 3 or so classes. You are making me very proud. And guess what? I'm going to hold you accountable for the duration of our time together, because you have the potential. I'm seeing the potential coming out. And guess what? I am truly, truly, truly proud of you. Believe in yourself, Papa. You can do it. All right, Pops?
Yes, sir. Yes, sir.
All right, nice. And there are others of you too who I'm hearing, you know, coming out more and speaking out more. Congratulations to you. But you know, I just had to big up my local friend Johnny just now. All right. So there's so many things. I don't even know where to start, students. I'm at a point now where, you know, when you have several things to do and you prioritize and say, you start this one first, and in the middle of this one, I said, no, but this one is not important. We start something else, and then you go around until you end up not doing anything. I'm almost at that stage. Why? Time is running. We have a lot to cover in a very short period of time. Plus, we have an SBA that I haven't even gone through with you just yet. To discuss with you. Now, I'm going to say this now, and I'll come back to it sometime later. But just to let you know that the other integrated math lecturer myself had a conversation. We don't have time for people to go and come up with their own school-based assessment, so to speak. So we have selected a topic. Is this the ideal situation? No, it isn't. It isn't, because if it's a school-based assessment, you should be able to, should be allowed rather to explore an area that you have great interest in, and there is a but. And you'll agree with me. The SBAs are doing another 2 weeks. And what the teacher did was to break where he was in order to go through that area so that you guys can have that information so that his students can have the information to answer the SBA or to perform the school-based assessment. So hopefully on Monday, I will take a break from calculus and just present that area to you. It's not a difficult area. It's an area under statistics. It's called regression and correlation, or correlation and regression. And I think it's going to be interesting. Now, here how we are going to be assisting you. The pair of us lecturers will get the data and put the data in a form that will greatly assist you. We're not going to ask you to do all of that. So I have requested the data and just awaiting now to get, I don't have all of them, just awaiting to get the rest, so it is that we can start, the lecturers can start the tabulating the stuff for you, so it is that you can go ahead and together do the calculations, because you'll have to do the calculations to present in your SBA. So we're going to teach you the topic, then we'll give the calculations to do in class, and then we'll take it from there. So what this SBA is all about. So correlation and regression speaks about the comparison of two variables. So I can speak of your attendance to class, and okay, let me tell you the variables that I speak. And I mean, I've always, I said to Sir, when Sir called me, I said, Sir, this has to be the working of the Holy Spirit. This has to be God himself that has spoken to you. I said to him, Sir, I don't know your religious beliefs, but I know where mine is. And I'm going to say to him, I said to him, I have been speaking about this correlation and regression, and just to get the confirmation from you. Have you ever heard me, or how many times have you heard me come to this class to say, sorry, there is a strong positive relationship between students participating in class and the grades received at the end of the first semester. Is it the first time you hear me say that?
No, sir.
How many times about you think I said that? From about when you hear me talking about that? Was it last class or the class before then?
Yes, sir.
Okay. So this has been on my mind. And it has been on my mind. Who is that? Newton Chan. Can you?
Yes,
Can
sir.
you?
Yes,
Are you
sir.
speaking? You
Oh,
speaking?
no.
Okay. Okay. Can you mute for me, please, on? Thanks. So this has been on my mind, and when Sue suggested it, I said to sir, sir, that's exactly where the Spirit of the Lord going, because I have been saying to the students, there's a strong positive relationship between their participation in my class and the grades received. Now, what we are going to be looking at is there a strong positive relationship? Say my hypothesis, is there a strong positive relationship between, looking at the two variables. One variable, we're looking at CSET math and English pass CXC results prior to the SBAs and after the introduction of the SBAs for the math and English. So I think it's going to be interesting. Matter of fact, out of it will come an opportunity for us to present at our research day that is fast approaching. I think research day is the 18th of May. You all may not be available because you have your exams will begin the 2nd of May. So I said to sir, I said, sir, worst case scenario, you and I can present the findings. I'm very excited about it. I hope you too will be excited. Why am I excited? You can only be informed on some areas, such as the one that we're going to be looking at, the proposed area, by looking at the empirical data. We can't just say, yeah, man, the students do better because of the SBA. We have to look at what the data says and be so guided by what the empirical information that we have is speaking to us. I mean, math is such a powerful discipline. It speaks volumes so loudly that our decibel levels will have to be taken into consideration. So I'm hoping that by Monday, I'll get the rest of the data so that I can share it with you and that we can speak. Now, we're not going to be doing an individual SBA. We're going to be looking at grouped SBAs. And chances are I may put 4 or 5 people in a group. So it is that we can together do the calculations and do the analysis, do the write-up. We're going to be having one of these nights. Seeing that we are meeting at night and the other group should be able, they don't have a class at this time of the night or evening into night. So I'll invite them to the SBA session. I'm going to conduct the SBA session. So again, I'm going to be losing, oh Lord, should I do that? I'm going to be losing a session with you, to facilitate this SBA stuff where, we tell you how, talk to you how to, the format of the SBA, the introduction of the SBA, how to do your data analysis, to let you know what it is that you're looking forward to. And I'm going to see if I can do like a PowerPoint presentation and then circulate the presentation to you guys, so it is that you can have the information to refer to when it is that you're going to be doing the stuff. So look out for it, listen out for it. It promises to be informative. As I said before, I am excited about research. I like research. My only difficulty about research is that I don't have the time to do the number of research that I really want to be involved in. But I love the information, garnered from any given research. So by Monday, I should be able to come up with a little bit more so that we can get the ball going. Are there any questions before I move on?
No, sir.
No.
Thank you. All right. So what was the last thing I did in class again? Anybody remembers?
The same question that Miss went through.
The same questions that Miss did? Did I not move on from those questions? Sorry,
So
I
I
got
give
cut off.
us that as an example.
Okay, and that was a piecewise question?
Yes, sir.
Yes, sir.
Okay. Mhm. Remind me of the question, please. Which question, the last question that Miss just looked at? The half x plus 3 and the 2x plus 9 and the 11?
No, sir, not that one.
Which one? Tell
Sir,
me.
example 3.
Example 3. The 3x plus 7 and the x squared minus 5?
Yes, sir.
Thanks. Again, you have to stay with me because I have, oh, sorry, I'm not sharing. All right, so here goes another example. I'm giving you 3 minutes to complete that example for me. Guys, remember, time is against us. I don't want anybody to feel that I'm going to be running away and leaving you. That is not my intention. But I'm going to ask you to see how best you can work along with me. I won't leave you, but for sure I'm not going to be able to spend 3 hours on one thing. I have to move into 3 different things within the 3 hours in order to complete the syllabus. So I'm giving you 3 minutes to do that one for me. All right, start now, please.
Sir,
I'm here.
I'm finished.
All right, what you got for your answer?
It's continuous. 6 minus x, where x is less than 1 is 5, and 2x plus 3, where x is greater than or equal to 1, is also 5. So it's continuous.
Yeah, but don't just say it's continuous. It says continuous at x equals 1. All right. So it's important that you say x equals 1 because
Yes, sir.
right, very good. Very nice. Is there anyone in the class that is still struggling with this one? Speak up now. I don't want when Mrs. Senningham doing the revision, he say, oh, I don't understand this. I'm giving you an opportunity to speak up. Look at what I have on screen and tell me if this is what you had on paper. If not, allow me to explain to you. Okay, not hearing anything, so we're moving on. I don't have the time to waste. You're not talking to me, I'm moving on. So here goes another question. Here goes another question. This one now is asking if p of x is continuous at x equal 1 and x equal 2. And to get you all to participate, let me tell you, Kamisha, you're going to let me know whether or not it is continuous at x equals 1. And Manisha, you're going to do x equal 2 for me. So Kamisha, you're going to let me know about x equal 1. Manisha, you are to tell me about x equal 2. On the mark, get set, go. Start for me, please.
Sir,
Yes, please.
sir, the something on black question.
It's true. Sorry. Thank you. Sorry about that. Something came up on the thing. Sorry. Hello? Is anybody there?
Yes, sir.
Yes,
We're waiting on
sir.
you.
Yes.
Okay. But I told her to say something to me in the finish, no?
Not in those words.
Okay. All right. No, man, I'm here sitting waiting on you. Okay. So, Kamisha, I see that you're ready for me because you log on another time in another device. So come. Walk us through this one, come. Manisha, you're next. X equal 1. Kamisha, unmute, please. Kamisha, we're waiting on you, honey. Kamisha, waiting on you. You just unmuted a while ago, and then you... Kamisha, I'm waiting on you. We are all waiting on you. No, we can't read. Me want you unmute and talk. Me can't read. No. Unmute for me, please. Thank you. Kamisha, going once, going twice. I'm going to put you in the waiting room, Kamisha, if you don't unmute to speak to me. All right, so Kamisha's mic is not working. Manisha, can we go with x equal 2, please? And then we'll come back to somebody else for x equal 1.
Sir, I got 7.
You got 7. All right. Is she correct? Is money correct? She got 7. Is she correct? Talk to me, guys. Manisha got 7.
Yes, sir.
Yes, sir.
She's correct. Okay.
Yes,
All right.
sir.
All right. Thank you, Manisha. All right. So let me go through the first part. Kamisha said that her thing not working. So let me go through the first part. Kamisha, please pay attention and make sure that you are following. I soon look to see if what it is that you put in the chat is what it is that I have here. Now, the reason I am interested in a question such as this is that you'll recognize that the first piece here, x squared minus 1 over x minus 1, is indeterminate. Do you agree?
Yes, sir.
Yes, sir.
Mhm. So it's indeterminate. So because it's indeterminate, you have to do something else. A question like this is not a 3 marker or a 4 marker. it has to be a 7 marker, 8 marker, or even a 10 marker because you have to do a whole lot more work. So when you go ahead and substitute your values, you recognize that you're getting 0 over 0. 0 over 0 is indeterminate. And that indeterminate form is suggesting that there is something in the function preventing the true limit of the function from coming out. We now need to either factorize, simplify, or rationalize to get rid of that little teeny unsy something. All right. Now, Manisha, don't tell me whether or not it's continuous or discontinuous, but I soon come back to you.
Sir, continuous.
Continuous. All right. Thank you, hon. Now, so this is what is happening now. So because it is indeterminate, which is actually the first thing that you need to check for. Right? So we need to isolate what is preventing the true limit from coming out. All right, very important. So I recognize now that my factorization is what I'm going to be using. So I recognize also that x squared minus 1 is the difference of two squares. And when the difference of two squares, x squared minus 1 is going to simply be x plus 1 times x minus 1. We should all know this. And we should all know this from liquor school, right? From liquor school. So we are going to be having x minus 1 times x plus 1, and voila, the x minus 1, that little something there that is preventing my true limit from coming out, just showed its ugly face up. Is the x minus 1. So I'm going to isolate it, and then I'm going to be left with my x plus 1. I'm going to be left with my x plus 1. Now, as the limit tends to 2 of x plus 1, I'm going to substitute. So the limit tends to, no, not 2. The limit tends to 1 of x plus 1. I'm going to substitute 1. So 1 plus 1 will give me 2. So I'm getting 2 here. Remember, I'm looking to the left of 1. That superscript, negative, is saying to the left of 1. Looking to the right of 1, greater than, refers to the right. So greater than, that means 5x minus 3 is a function that deals with greater than, or to the right, which is why I put it here. 5 times 1 is 5 minus 3 is 2. So because both are tending to the same function, it means that they're of a good behavior. And I can say that the limit exists and it's continuous at x equals 1. So P of x is continuous at x equals 1. Now we need to investigate what happens at x equals 2. At x equals 2, I'm looking to the left. Now, x is less than 2. Suggests that this function is the function that deals to the left of 2. And x is greater than or equal to 2 is the function that deals to the right of 2. So one deals to the left of 2, one deals to the right of 2. So to the left of 2, I'm going to have 5x minus 3. See it here? Superscript negative is left, 5x minus 3, and my 2x plus 3 is going to be the right. When I substitute 2 here, 5 2 is 10 minus 3 is 7, and 2 times 2 is 4 plus 3 is 7. So again, because both are tending to the same limit, I'm going to say that P of x is going to be continuous at x equals 2. Easy peasy. Now, my question to you is, are there any questions?
No, sir.
No, sir.
Let us see what.
So the both of them continuous, sir.
Yeah. Okay. All right. So Kamisha just corrected herself. All right.
Sir, you
All
can
right.
please.
You want me to scroll up?
Yes, sir.
That's fine, or further up.
That's fine, sir.
Mhm. All right. Very important, guys. We really want you to participate. We really want you to see what is happening. We really want you to be able to conquer this little something called integrated maths. This is not anything that should cause us to lose any sleep. Easy 1, 2, 3. Easy 1, 2, 3. Easy 1, 2, 3. So I'm having class tomorrow with my business calculus students, and I'll be sending you guys the link, inviting those of you who can make it and understand. It's not late notice because I told you about this on Monday, but those of you who can make it, I'm going to post a link in the WhatsApp group. Those of us who can make it, I invite you to come. You'll be able to see, where am I with them, Jesus? I think I'm here piecewise with them too. You can see what is happening. I'm sure I'm going to be going over something briefly on this. You can see what is happening and hopefully move on ahead of the class. So when we come back on Monday, you will be breezing through what it is that we're doing. All right. So I'm inviting you all. All right. May I move?
Yes, sir.
All right. Good job. Proud of you. Proud of you. Now, this question is a past paper question, a CCCJ past paper question. This is a CCCJ past paper question. And I looked at it and I thought to myself, interesting to see how well they will look at it. So it's, Lord have mercy. Yes, so interesting to see how well you look at it. There is a little issue with this question, however. What is the issue, sir? The combined inequality is AX plus B. But sir, you never do no question like that with us. I'm very aware. I'm very aware. What I want the class to do for me though, this is me going through this topic with you. You are saying to me that you're understanding, and I'm now stretching you to see how much you understand. Read this. What function is this function again? 2x squared minus 4x plus 2. What we call this?
Trinomial.
It's a trinomial. Does it have another name?
Sir, repeat.
Does it have any other name? So Tony says a trinomial. Yes, it's a
Linear?
trinomial. No man, can't be linear because it's a square.
Quadratic?
Quadratic.
It's a quadratic. Good. Any other name? And those two names are correct. Any other name? I told you a secret the other day that when you're evaluating something of this nature, something can't happen. You'll never, ever, ever get something like something because this one is just always a good behaving something. What something am I talking about? It is a starts with a P. Then a O.
Polynomial, sir.
Polynomial.
Polynomial, very good. So can I get something that is indeterminate with a polynomial?
Yes, sir.
Say no, say no, say no.
No.
No. So the limit of a polynomial is going to be defined at every point. So you notice what they say here? Determine the values of A and B such that f is continuous over the interval x is greater than negative infinity, but less than infinity. You know what this means? It says it's continuous over that interval. So at no point in time, this question, f of x, can give you something that is going to be indeterminate, or going to give you something that is going to be discontinuous, or going to give you something that you can't evaluate. At no point in time. Here, so, I couldn't have said the same thing. I couldn't have said to you from negative infinity to positive infinity. Because even though we got it to be continuous at x equal 1 and x equal 2, this piece here, this rational function here, is problematic. This rational function here is problematic. This function, on the other hand, isn't, because at every point on this graph, the graph is going to be continuous. And the question told you. So we now need to determine the values of a and b. That will make f of x continuous over the total interval, negative infinity to positive infinity. It means, say, so when you talk about negative infinity to positive infinity, it means that you are taking into consideration every single one of the points. There's nothing left untouched. All right, so let's go. I want you first to evaluate the limit to the left of -1 and tell me what you get. Evaluate the limit to the left of -1 and tell me what you get, please. Please let me know when you are finished.
Finish, sir.
What I got for that answer to the left of -2? I'll think about it, Cassie. What you got to the left of -1?
Sir, I got 8.
Anybody else got 8?
Yes, sir.
All right, so you got 8. All right, no. Look at what is going to happen. I want you to tell me something. Father God just laid something on my heart. And I'm going to say it's him because I am looked to for my strength over these many years of teaching. That there is somebody in the class that is just not with me, not focusing, not learn nothing. And we have an opportunity to say, sir, I'm not following. And again, I'm going to say to you, there's a strong positive correlation with those who participate in class and the grades received at the end of the first semester. There will be a strong positive correlation for those students who participate in class and the grades received at the end of the school year from CXC. I don't know what else to do. I don't know what else to do. I've actually exhausted my options, I believe. Tom, let's go back, please. I'm going to be asking some questions now. And this is going to tell me whether or not you are understanding what is so required of you. So you evaluated the limit of the polynomial 2x squared minus 4x plus 2. And you all agree that 8 was the answer. You all agree that 8 was the answer. If this function f is continuous over the interval negative infinity to positive infinity, it simply means then to the right of negative 1, what should be my answer?
8.
8.
Very good. Excellent. Bravo. Bravo. Now, what do you think I should write for the limit as x tends to negative 1 to the right? Tell me what you think I should write. Think about it. Think about what you have been doing all along. Tell me when it is that you have done all that you're supposed to be doing, and you're checking your limit to the function as it goes to the right, what it is that you've done. Talk to me. If you say you understand conceptually, this should not be a problem. John Mark, what say you?
So I'm thinking, sir. I'm thinking, so I'm thinking.
Oh, you're thinking. I didn't hear you. You're thinking. Nati, what say you?
Sir, about what? I'm just coming. Sir, about what?
What do you think my next step is? Tariq, what say you?
Sir, at x equals -1?
At x is, no man, no. To the right of -1. Tariq, what you said?
I'm not.
Huh?
I'm thinking about it.
You're thinking about it, okay. Patrine, what do you think?
So I'm thinking.
I have a lot of thinkers tonight. Tati D, what do you think? Are you thinking also? Tati G, what do you think?
Sir, x tends to negative infinity.
Are you understanding what I'm asking?
Sir, repeat what you're asking.
Okay, so we've evaluated the limit as it tends to the left of -1 by substituting the value -1 into the polynomial function. and we got 8. You told me you got 8, and I agree that it's 8. But I'm also saying to you, I have ax plus b, a linear function, as the limit tends to the right of -1. I am saying to you that the function f of x is continuous over the interval -infinity to +infinity. I'm asking, what do I need to do with the limit of the function as x tends to -1 to the right? What should I do with that function, the middle function? What should I do with it? You've been doing it for the last couple of questions. One question Miss did with you, and since I've been here with you tonight, you've done maybe 2 or 3 questions for me. What is the next step? Anybody? Please, somebody.
Sorry, you could just put -1 where x is in the function.
Very good. Excellent. All right. So my question to you. So Tanya says, sir, just as we've been doing, just substitute -1 for x in ax plus b. Can you all see that?
Yes, sir.
There is something else though. There's another thing to put in. What should I put in there now? Thank you, Tanya. There's something else.
Sir, the 8.
Where do I put that?
Probably equate it to 8, I'm not sure.
Okay, why would you equate it to 8?
I don't know, you know, sir. I just
Think about it. If I say it again.
Because you're finding the values of A and B, so yes, you're going to equate it to the 8.
But no. So tell me why I must equate it to 8. Okay, yes, Daniel, I'm going to equate it to 8. All right, Shan, tell me why it is that I'm equating it to 8. Don't tell me again that because I'm trying to find the value of A and B. That's not it. Tell me why I must equate it to 8.
So is it because when you did do the thing, it did equals to 8 when it did tend to +1, or to the right of the left of -1? I don't remember where it is.
Okay, yeah. Okay, so you're correct, Nathalie. But tell me why.
Yeah, because the function is continuous.
Very good. Do I have to squeeze you guys to get information? Because the function is continuous. So if the function is continuous, it means that the answer I get for the polynomial up top have to be the same answer that I get for the other one in order for it to be continuous. Remember, you know, the two, something that must be equal, or else we say that it's discontinuous. So watch me. Watch me. I'm happy that I got the answer, but sad that I had to be squeezing it. So to the right of -1 is going to be ax plus b. To the right of -1 is going to be ax plus b. Now, just as we have been doing for all the questions, I am going to substitute -1, I'm sorry, into the function. So I'm going to say anywhere in ax plus b, I see x, I put -1. So I'm going to have a times -1 as I have it right here, plus b. And -1 times a is -a plus b. Why, sir, did you equate it to 8? I equated it to 8 because the question says I need to find the values of a and b such that the function f of x is continuous over the interval -infinity, sorry, to +infinity.
Sir, that's it.
That's it. Only because it is continuous why I equated to 8. That's the only reason. All right. So I'm going to leave this question as it is just now. -a plus b. This is a linear equation, and I cannot solve a linear equation with 2 unknowns. Can anybody think of something else that may happen that I can able to solve for a and b? All right. I'll come back to that one. Let us look at to the left of, what should I say to you? Whenever I do questions like this, you don't have to be like me, but whenever I do questions like this, where I have unknowns, I jump to the third one. I look to the right of the function before I look to the left. Because when I look to the right of the function, it will guide me to the left. But if you want to look to the left first, I can't kill you. So help me look to the right of this function as x tends to 1. And tell me what the answer is supposed to be.
Sir,
What is the
12?
limit? Very good. Very good. Can anybody else see why Tanil got 12?
Yes, sir.
Yes, sir.
Yes, sir.
Very good. All right. Nice. Nice job. Nice job. All right. I don't finish with you yet, you know.
Sir,
Not
what was
finished
the
yet.
question a while ago?
Huh?
What was the question a while ago?
I wanted you to evaluate the limit as a function tends to the right of 1. And the answer is 12. Do you agree 12 with 12? Hmm?
I'm not too sure, sir. I don't know what is happening at all.
Say it again.
I'm not sure, sir. I don't know
12.
what was evaluated a while ago to get the 12.
Watch me. So what I'm saying to you is that I will normally solve to the right of the function first to see what is happening there. Then I look to the left. To the left of the function is also going to be ax plus b. And when it is 1, I'm going to have a times 1 plus b. But in order for this function to be continuous, since this one here tends to 12, that means this one here must tend to?
Oh, the 12 also?
Right, for it to be continuous. So in order for the function to be continuous over that interval, they must both be going to the same number. So therefore, I'm going to have a plus b now equals 12. Now look at this. I have one to be negative a plus b equals 8, and the other to be a plus b equals 12. Now, the only way I can solve those two equations in two unknowns is by using a simultaneous solution. And the simultaneous solution is going to involve me solving negative a plus b equals 8 and a plus b equals 12. And because Sir has gone through simultaneous equations with you already, I'm going to give you 4 minutes to solve that pair of equation for me. Please let me know when you are finished solving.
Finish, sir.
What's the value of A?
A equals 2.
And B equals?
10.
Okay. Guys, we need to go in, so I'm not going to wait on the rest of, I'm going to project it and you can check to see what it is that you've done so far. So B is equals to 10, very good. And A is equals to 2. All right, so I'm going to leave that there for another 2 minutes so that you can, those of you who are still working can finish your thought. 2 more minutes. All right. Are there any questions? Can you all agree with my A equals 2 and B equals 10?
Yes, sir.
Yes,
Yes,
What
sir.
is
sir.
nice? Good job. So what this question is saying, when the value of A is equals to 2 and B is equals to 10, that's something here is going to be continuous over this interval. If A and B take on a number other than 2 and 10 respectively, then we have a problem. But once it is 2 and 10, it is going to be continuous over the interval negative infinity to positive infinity. Now, what is important is that you understand this, because I know the examining bodies love to give them unknowns inside of them questions here. And trust me, let me ask a question, by the way, without me asking you to trust me. The solution to this question, is it different from how it is that we have been doing the other questions in terms of looking at the limit from the left to the right?
A little.
How so? Tell me how.
So you're still substituting, but it's just that you have unknowns like the A and the B.
That's what I'm saying to you. We're not talking about the simultaneous solution. I'm talking about the methodology. So the methodology, we're not talking about arriving at the A and the B just yet, I'm speaking about the methodology. The methodology is the methodology to get the A and B. Is it different from what it is that we have been doing before?
No, sir.
No,
It isn't.
sir.
It isn't. Because this is how you are able to tell me, Tani, that when I look at the limit to the left of -1, I get 8. So therefore, the limit to the right of -1 should also be 8 if the function is going to be continuous. If the function is going to be continuous, it has to them two here must be the same. Sir, we are talking about. See, them two are the same, it is continuous. See, them two are the same, it is continuous. See, them two are the same, it is continuous. See, same, continuous. Bam, different. D for different, D for discontinuous. So once them different, them discontinuous. So the numbers must be the same in order for you to have continuity. The numbers must be the same in order for you to have continuity. But right here, we normally look to the left of the function first and then the right of the function after. But in this case, I said to you, let us look at the right first. So at least we know what the limit is going to be. So when we look to the left, we can go ahead and substitute that value right there. And then now when we finish here, so there's only one more step. What is the step, sir? We need to find the value of A and B, so we can't leave the question like that. So in finding the value of A and B, what we now need to do is to go ahead and solve simultaneously. And my simultaneous solution will give me the values of A and B. And I'm not going to flow through the simultaneous equation because I've done that with you before. All right. Any questions?
No, sir.
No, sir.
One of the things that I'm going to say to you, I'm your biggest cheerleader. All of you. Whether or not you want to talk to me in class, I'm your biggest cheerleader. I believe in you maximum percent. Maximum percent I believe in you. Whether or not you believe in yourself, this is one teacher that give up on their students. I fight with you to the very end. But more you fight with me. You can't give up on me and go on galang say me so. I'm flogging a dead horse. Horse decides him now move, nothing can happen. But if you continue going with me, you're good to go. I'm going to see how many of you have the longevity to fight through this. Stick-to-itiveness. That's what we're going to call it. Watch me now. We're wrapping up continuity to move on to unit 2. See me have one next one there. Start for me, please. All right, sorry guys, I had to step away a moment. Are you finished? Hello, somebody?
Soon, sir.
All right, cool.
Finish, sir.
Nice job. What you got for the answer for A and B?
I got a quarter for A and 2/4 for B.
We need to have a conversation. Did you get did you get the limit here to be 2 up top?
Yes, sir.
Remember the limit of a constant is the constant itself. Remember that one?
Yes, sir.
Yeah, so both of them. So you should have minus, did you get negative A plus B equals 2?
Yes, sir.
And did you get 3A plus B equals negative 2?
Sir, that's the problem. The negative 2.
Come on, remember you're substituting 3 into the function. And it's supposed to be equal to negative 2. Negative 2 is supposed to be equal to. All right. Let me leave it right there. I start with the simultaneous equation for me again, please. The rest of you, please look at it for me. Thanks. Please, 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 please.
Sir, I got the answer now.
All right. What about John Mark? What about you, Papa? Tyreek, what about you? Pestana, what about you? Shante?
Yes, sir.
I'm not fully convinced yet.
Sir, it's just the 3 confuse me, sir.
This is my final question. And this one don't even include the unknown. I know what I need to write for you as homework. All right, do this one for me, please.
Yes, sir.
Answer.
Sir, f of x is continuous at x equals 5.
Okay, thank you, Santon. John Mark, do you agree?
So I'm not finished with that understand.
Okay, I'll give you a few more minutes, John Mark. Georgina, do you agree?
Yes, sir.
Okay, thank you. Manisha, you agree? Aniki?
Yes, sir, I never finish. You know, move fast enough.
You know that? I'll give you a couple more minutes. Class won't finish now. 45 more minutes to go. Oh, Lord, help me. All right, a few more minutes. Shout me when you're ready, please. I'm sitting right here.
Sir?
Yes, son.
Sir, the reason is just writing the statement that they're equal, x is equal to 5. That's the reason.
Yes.
Okay.
Yes. Yes.
So what did Anthony say for the answer?
No, tell me what you get.
8.
You get 8. All right.
So I'm finished, sir. Continuous
No,
at x equals 5.
what you get, John Mark?
Continuous at x equals 5. Later.
What's the answer you got? You got 8
Yes, sir.
for both of them?
Yes, sir.
All right. So you see, you can't tell me say the answer is 8. If you tell me say the answer is 8, I'm going to tell you say you're wrong. The limit approach is 8, but you're going to tell me that it is continuous at x equals 5. So the reason is since the limit as x tends to the left of 5 equals 8, and the limit as x tends to the right of 5, which is also equals to 8, then it is continuous at x equals 5. I did say that was the last one. I have another question here. Run this, please. 2 minutes. Can't, 3 minutes. Something for the easy question. 2 minutes.
Sir, finish.
All right. I like the sound of that. Tell me what you got for your answer.
Sir, they're not equal, so they are discontinuous at x equals 3.
I disagree with you, but never mind. Let us see if somebody else gets the same thing as you or somebody else agrees with me.
A baby son was
Let me see if somebody else agrees with me or agrees with you.
Sir, I don't get equal either.
So what do you say? I'm trying to you to speak the
Discontinuous.
jargon. It is what? You get it to be what?
Discontinuous, sir.
What do you get it to be? Manisha.
So is
I'm asking you what did you get for your answer?
sir about 41 and 39.
Manisha, if I beat you tonight, you see, you cry for mommy and daddy and grandma. Listen to me. Not 10 minutes 49 and something like. Is it continuous at x equals 3 or is it discontinuous at
Sir,
x
you
equals
said
3?
discontinuous.
We never hear you. That's what I'm asking you. All right. So you said discontinuous. All right. I will say the beating for later. So you and Tanisha said the same thing and I disagree. Not to be, I saw you on mute. Talk to teacher because I don't know where them two they get them answer there from. Not to be.
Sir,
All right. You don't.
I said discontinuous also. I didn't get equal
Wow.
answers.
All right. I don't know
Sir,
what you
you're
guys.
wrong.
I'm not wrong at all. I know there's a trick in the question, and you guys just got caught. John Mark, help them for me, please. Terry, help them for me, please.
Yes, sir, I'm going to get discontinuous at x.
I got this.
Equal 5.
Well, clearly, I have to reteach this topic because none of you understanding what I think
Sir, you
that I'm
need to
doing.
reteach it to yourself, sir.
All right, woohoo! My students got it. Thank you, Jesus. I'm happy. I'm very happy. All right. Now, Momo.
Sir.
Anisha? All right. So I hear you when they said 49 and 39 and 41, but don't get caught up in the 49 and 31. Those are just the limits, right? So if you're going to tell me 49 and 31, say to me, sir, the limit to the left tends to 41 and the limit to the right tends to 39. But really and truly, the question says, Given that f of x is all of that ugly looking something, determine if the function is continuous at x equals 3. So in telling me your answer, you should say to me, sir, the function is continuous at x equals 3, or the function is discontinuous at x equals 3. When it's a 41 and 39, you're not answering the question. You get me, honey?
Yes, sir.
But guess what? I'm really proud of you. Really, very proud of you. Really. I'm just telling you, you know the topic. Go away, but we must teach myself. Go away. All right, let's go. You notice what I put right there? Discontinuous or not continuous, both are synonymous. So if I say discontinuous or not continuous, I get the same mark. So if something is not continuous, it is discontinuous. Fair enough? Now,
Yes,
I went ahead and did a little summary just to finish off the topic, because the topic finished, you know. We finished with unit 1, thank you, Jesus. Let me just reduction this little bitish. I'm not going to bigify it any bigger, because I want you to see everything on the paper. So I did a little summary for you guys. I did a little summary. And I want us to read the summary. I'm going to read the summary. You tell me if you agree with it. It's a summary for evaluating piecewise functions. One, you're going to investigate what is to the left and right of the given limit. True or false?
True.
All right.
True.
Good. Then A, you're going to substitute the limit into the functions, left function and right function, and evaluate the functions. True or false?
True.
All right. And in the second piece now, if the limits are equal, then we say that the function is continuous. If the limits are different, then we say that the function is not continuous or discontinuous. True or false?
True.
Okay. So this is when it is that we're evaluating the limit of a function. This is when we're evaluating the limit of a function. I need to change something. I don't like how I word it. Okay, all right. All right, okay, fine. I'm speaking specifically about piecewise functions. All right, fine. Then now, sometimes I write this stuff, guys, based on what is in my headspace, and then when I look back at it, I didn't like it. Let me tell you where I was going. I was going to put something general for the limits, but now this piece of the thing here is on piecewise, so let me keep it as piecewise. Now, if the piecewise function contain unknowns, you will investigate what is to the left and right of the given limit, which is the same thing like up here. So talk truth.
Yes,
Yeah, no? Good. Then you're going to substitute the limit into the functions, left function and right function, and then equate. Repeat this step with the other set of functions. And then we're going to solve equations simultaneously to evaluate the unknowns. Don't it?
Yes.
Yeah. And when you say, and when we have this here, we say bright. We say bright. No, let me just tell you something. Let me just tell you something. When Mrs. Ellingham and myself were going to school, though different eras, I can't recall any teacher writing a summary of them something when me I go to school and learn them topics, you know. Cannot. Mrs. Ellingham, can you recall? Because I can't recall. Wait,
No,
Mrs.
sir.
Ellingham, go sleep?
Not at all.
Oh, okay. Not at, yeah. So I'm saying to you, students, we never have this sort of luxury. We never had this sort of luxury at all. And sometimes you go to class and it's like, oh, you got 3 hours? When I was in high school, you used to get like 35 minutes and 45 minutes per session. So if you're having a double session maybe about an hour. And they were gone to either chemistry class or physics class or that subject they call history. Oh God, I don't know how anybody do that subject. But anyway,
Right.
that subject, yeah, trust me, talk truth, enough truth, right? So I'm saying to you, know that the pair of us, Mrs. Hannah and myself, are making these notations because we really want you guys to read. When you get these handouts, please read through them. Go through the something because it makes life so much easier. So this one is finished. Hallelujah, praise the Lord. It's finished. Now, I'm going to give you a 5 minutes break because I am on to differentiation. And I'm going to do differentiation from first principles. And guess what? We're not planning to do 4 and 5 examples for you to catch it. All right? Oh Lord. Okay, yeah. Oh, I'm supposed to do this one with you first. You know what? Nope, I'm not doing that first. I'm gonna dump it. I prepared some notes for you, but I forget that this sort of the first part of things. But I did this with you before. I did that with you before. Okay, never mind. I'll just start from there. All right, I give you a 5 minutes water break. Please do not drop asleep. A 5 minutes water break. We'll come back at about, yeah, we'll come back about 5 minutes past 8. So I can go through. I want to introduce you to a few of the rules for differentiation. Because differentiation now also for you includes the trigonometric ratios. So this is going to take a while. So I just want us to go through this quickly. All right, take a bit of break and then come back. 5 minutes. We're coming back at 3 minutes past. All right, 5 minutes past 8. It's now a minute to 8. All right. So I hope you had a water break. I did. Mrs. Henningham reminded me that I did promise you that I was going to show you something on rationalization. Oops, I just totally forgot. All right, let me do this very quickly. And so when we're looking at the limit of a constant, for argument's sake, I use rationalization to bring across the point of the limit of a constant. So I'm given this limit to evaluate, and let's go through this quickly. The limit as x tends to 9 of 3 minus the root of x over the root of x minus 3. All right, so let us go. 9, the root of 3, sorry, the root of 9 is going to be 3, so 3 minus 3 is 0, so the numerator is 0. And the root of 3 minus 3, the root of 3 is 3, 3 minus 3 is going to be 0, so I'm going to have 0 over 0. So I know this is indeterminate. So one of three things: factorization, rationalization, or simplification. Let me try to rationalize it to see what happens. Now look at what I have in pink. When I'm rationalizing, I'm using the conjugate of the denominator. So what do you mean by conjugate? The opposite. All right, so you have the root of x minus 3 here given. It means then that when I'm doing it, when I'm rationalizing, I'm going to have the root of x plus 3. So when you conjugate something like this, the conjugate of it is just going to be the opposite sign to it. Huh? And whatsoever I put, the conjugate is going to be the same thing in the numerator as well as the denominator. I'm going to ask you a question, so I want you to listen. So you notice now that I'm using the opposite of the root of x minus 3 here and the root of to the root of x plus 3. Why am I dividing here by the root of x plus 3 over the root of x plus 3? What does it do to this? It's as if, continue that statement, it is as if what?
Sir, this something cheap out. You can, sir, after you say you use the opposite, what you say after that?
Right, so I'm using the opposite here. So you recognize that my denominator is going to be the root of x minus 3, and then I'm going to have the root of x plus 3. I'm asking you, I'm using the conjugate, I'm using the opposite of the root of x minus 3 as the root of x plus 3. It's just the signs that we change. But you notice what I have in the denominator is the same thing I have in the numerator. What does this do to my original question? Why do you think I have the same thing up here, so, and down here, so?
Sir, because it constant.
Because what?
It constant.
Constant, no.
So they cancel each other.
And then what happens when it cancels each other?
Sir, if they cancel each other, you're left with the original question then.
Why?
Sir, because nothing of it not gonna like equal to 1 or something.
Say it again, not be. You're not going to equal
to 1.
No, what you say?
Sir, if them cancel out each other, it's gonna equal to 1, so it's gonna be like the original question.
And that's why I tell you, say you just want too big lick when you don't do your work, but you don't understand. That is very good. Very good. You want too big lick, so it is that you know what happened. I mean, not talk about abuse, you know. Too big lick will just shake you up. Because Natty B, that's very good. That's excellent, Natty B. Let me tell you what she said, guys. We have the numerator and the denominator to be the same thing. So it's as if you're multiplying by 1, and 1 is a multiplicative identity. So you're really not changing the original question. Natty, unmute for me, please.
Sir.
I want you to stop doubting yourself. You hear me, ma'am?
Yes, sir.
All right, thank you, please. Don't let me fall out with you. Stop doubting yourself. That was an excellent response. Thank you. Now,
Yes, sir.
so students, this is what is happening here. I have the root of x plus 3 divided by the root of x plus 3. It's as if I am multiplying by 1. Sir, how so? You have the root of x plus 3 over the root of x plus 3. I'm multiplying both numerator and denominator by the conjugate of the denominator in the original question. But I'm putting the same function up top as I have down the bottom because it's as if I'm multiplying by 1. It's as if I'm multiplying by 1. Put it this way. Something just came into my spirit. It's like you cooking a nice pot of chicken foot soup, nice yellow piece of dry pumpkin, get a nice rich color. But inside of that soup, you drop a pepper in there because the pepper flavors the pot. And you drop your scallion and thyme, and that's something that me like use, but I don't like bite it. It's called pimento. Jesus, Father, make me have my last piece of meat in my mouth and go bite all one piece of ginger or piece of pimento. I mean, no, I have to go spit out everything. I'm vexed. You better take a piece of meat out of your plate and put back into my plate if it's you share my food. Because me very vexed. You know what I also don't like? When it's Christmas time and I cut piece of ham and I say, yeah, me I make a nice little sandwich and piece of the cloves, eat up in the ham and me go bite the nicest piece, the piece in the middle, where you're ready for just say, you know what, you bite on everything and just leave the middle piece and say, yeah, I'm going to sort it out, bam, you bite it, piece of cloves. And you say, oh my goodness, it just nullifies what it is that you're going through with this sandwich. That is it. My pimento, my scallion, my thyme, all these additives that I put in the soup, I'm a pepper on them, something there. It is to flavor the soup, and when it don't flavor it, never take it out. Nobody shares their food with pimento in there, well, hopefully, and scallion in there, and thyme in there. No, it serves its purpose. You put it in there to do a particular purpose, at the same thing. This here so is my seasoning, all right? Now let us do the multiplication. The root of x times the root of x. Oh, so this is what it works out to be. The root of x minus 3 times the root of x plus 3, see here so? And this works out to be the root, 3 minus the root of x times the root of x plus 3, right here. Then I'm going to do the multiplication. Watch me. 3 times the root of x is going to be 3 the root of x, right here. And the root of x, rubbish. And 3 times 3 is going to be 9, right here. Let me spotlight this so that you can see me better. And then 3 times negative the root of x times the root of x is simply going to be negative x. Because when I multiply the root of x by the root of x, I get x. Sir, how that? Remember x, the root of x is the same thing as x to the half. Indices and logarithms, the very first topic we did, x to the half is the same thing. The root of x is the same thing as x raised to the half power. And it is x to the half power. And this is another x to the half power. When I'm multiplying and the bases are the same, I add both powers. A half plus a half is a whole. So I'm getting rid of the square roots and I'm just going to be left with x. And then the root of x times 3 is going to be negative the root of x. So if you see what happens, oh, and the denominator is going to be the root of x times root of x is simply x, right here. And the root of x times 3 is 3 the root of x. And negative 3 times root of x is negative 3 the root of x. And negative 3 times positive 3 is negative 9. And you'll see now that these two cancel. See it right here, so? Them cancel out. And this one out here cancel that one. So I'm left with 9 minus x over x minus 9. So right there, so I rationalize the function. But let us check. When x tends to 9, this is 9 minus 9 over 9 minus 9. Even though I rationalize it, it still never helped me because I still get back indeterminate. I only did this to show you what rationalization looks like. All right. So I only show you what rationalization here looks like because I keep talking about it. But really and truly, it says rationalization did not work in this situation as we still end up with it. an indeterminate form. Let us try factorizing. And when we factorize a function, we recognize now that I can factor out a negative sign. Simple. See the question here? 3 lines. I factorize a negative sign from the original question. Copy. I say I got myself into trouble last night in a calculus class, you see. I copy some stuff for some students and I work. And the student says, sir, it is wrong. I said, how it is wrong? Sir, because is it true you love to copy and paste, sir? You copy and paste it and never remember to change over to something. I said, well, guilty as charged. Guilty as charged. That's the thing about me, you know. When I make my mistake, and I own up to them. I say guilty as charged and I receive my guilty call. All right. So recall, this is the original question. So what I'm going to be doing is factoring out a negative sign. Sir, how are you going to factor out a negative sign? I'm hoping this is a class I said it in, that in every positive number, there are 2 negative numbers. In every positive number, hidden, you find 2 negative numbers. So if I want, I can factor out one of the positive numbers, one of the negative numbers, and then I'm going to be left with only 1 negative number. So in every positive number, there are 2 negative numbers that are hiding. Why, sir? Because when I multiply 2 negative numbers, I get a positive number. All right, so each positive number has in storage 2 negative numbers. So I can take out any one of the negative numbers anytime I want. But it means now that the other negative number needs to show up itself. Look at me. So I know that I have 3 minus the root of x and 3 and the root of x minus 3. I rationalize the function up here, so. And when I rationalize the function, Lord have mercy. When I rationalize the function, it never works out because I still got the indeterminate form.
Sir.
I'm hearing you. Go ahead. Go ahead, please. Who is calling, sir? Okay. Still indeterminate. All right. So I'm factoring out. So look at what happens. John Mark, you're not hearing? No, man. Anybody else hearing me?
Yes, sir.
All right, cool. All right, so I'm factoring out the negative sign. And this is me factoring the negative sign out of 3. So 3 has 2 negative signs hiding. So when I factor out one of the negative signs from 3, see the other negative sign show up. So I see it now, because when I multiply this negative number to this negative 3, you get a positive 3. And I multiply this negative number by this positive number, I get a negative number. Are you following me?
Yes, sir.
Okay. I slow down deliberately because I want you to see it. There's a big thing about negative 3 and minus 3. Let me read it. 3 minus the root of x. This here is the operation. But when I'm looking at this number is now a negative the root of x. So you don't say 3 negative the root of x. You say 3 minus the root of x. But this, the root of x, is now a negative number. So it's a negative the root of x. All right? So when I recognize that in every positive number, there are 2 negative numbers. There are 2 negative signs in it. There are 2 negative signs in it. All right? Because when I multiply 2 negative numbers, I will get a positive number. So I'm accessing one of the negative numbers. So when I do that, I recognize that the root of x minus 3 can cancel out. I'm going to be left with -1. See here? And the limit as x tends to 9 of -1 is simply -1. So the limit of a constant is the constant itself. Am I clear right there?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
All right, no problem. I remember Matthew asking this question, and Matthew is not in class. I remember Matthew says, sir, you can show me order one of the rationalization look like, and he's not in class. All right, let me just go through this here quickly. So we're on to unit 2. We're on to unit 2. Differentiation. So it says that I'm to relate the derivative of a function with the gradient at the point of that on that function. All right. Was it you? It wasn't you, no. I had a class last night. Went up to 10 o'clock and I was showing them. You know, as teachers, we tell a lot of lies as teachers. I remember my chemistry teacher says, the outer shell will never have more than 8 electrons. We say, okay, calcium, what is the electronic configuration? 2, 8, 8, 2. All right, what is the EC for potassium? 2, 8, 8, 1. Good, because the K shell, the L shell, the M shell, they will not hold, the M shell and the N shell will not hold more than 8 electrons. So you know, say, me hold that in the 3rd form. When we reach 4th form and 5th form, and when we reach 6th form and teacher talk about 18 electrons. Me say, hold up there. Me say, what are you talking about? This can't work. Me say, can't work. Me say, my teacher was the best, and my teacher said it can only hold 8. It cannot work. No, it can. And that's where the transition elements come up now. And me say, oh, look back at the periodic table, because we only know from 1 to 20. But then afterwards, we'd have to go know from 1 to 30. Because I don't know what the chemistry syllabus looks like now, but we have to know the transition elements and how they operate, so forth and so on. The point I'm making is, when I was going to school, my teacher told us that negative numbers don't exist. So when I went to high school, I had that same concept. But then I learned that negative numbers do exist. And then one of the things, no, it wasn't a lie, but we just never told you, that when you're finding the gradient, y2 minus y1 over x2 minus x1, you're actually differentiating. You are actually differentiating. Teacher never tell me that. Or since me start teach me say, oh, Rockstone, and then something here. Teacher never tell me, so I couldn't relate both to what it is that we're doing. So it's not until I started teaching and you know, trying to make connections. I say, oh yes. Even though it was talking about the slope of a line. So watch me. What's the point? The point is, you have your parabola. People call it parabola, same difference, right? One sound like come from America, so that's a parabola. That's what the foreign people them call it. So you have your parabola here, which is defined by this graph y equals x squared. When x equals 0, y equals 0. When x equals 1, y equals 1. When x equals 2, y equals 4. When x equals 2, y equals 4, cut off up here, so, right? So this is my parabola for x squared. And I'm finding the gradient at the point 1, 1. Uh-oh, 1, 1. 1, 1.
Sir, we're not
1,
seeing the thing.
oh, Jesus, Father, forgive me. Forgive me. Oh, Lord Jesus. Oh, thank you, honey bunches. I'm going to sit down there and say nothing. Thanks here. So this is my parabola. That's my parabola here. And it's defined as for the function y equals, f of x is equal to x squared. So look here, f of x is equal to x squared. When x equals 0, f of x equals 0. See it right here, so? Sit down on it right here, so. When x equals 1, 1 squares is 1. So x equals 1, this is equal to 1. So it passes right here. When x equals 2, 2 squares is 4. So you go all the way up to 4. My 4 cut off on the graph, so you won't see it. All right? So this is what the parabola looks like in blue. The question says, given f of x is equal to x squared, find the gradient at the point 1, 1. Oh, so when I was in little school, and the question come like this and ask me to find the gradient at the point 1, 1, you know what I'm going to do? Draw a tangent. So my green line is a tangent. You know, I could do better with this drawing. I could do better with this drawing. I really want you guys to get it. T-A-N-G-E-N-T. I want you guys to get it. I want you guys to get it. I want you guys to get it. All right. So that line here is my tangent. And you know, again, put him down here. So, right, that line here is my tangent. Can you understand? We're not, no, but you cut off piece of something. What is wrong with you? No, son, and that's a tangent spur. All right, so that green line is my tangent. So I'm drawing my tangent at the point 1,1. See, I put my 1,1 right here. Yeah, put my 1,1 right there. So I'm drawing my tangent at the point 1,1. Oh, Father, friend. At the point 1,1, which is right here. So this green line is drawn touching this 1,1 angle at the point 1,1. And then now I'm going to finish off a triangle. My vertical piece, my horizontal piece. Then now I end up with something called my rise over my run. My rise over my run. Copy, paste. That's my run. Paste. Oh, undo, undo. That's my run. Paste. All right. And down here, so we can call my rise. No, do that. R-I-S-E. I mean, hit it up in here, so hopefully it works.
So rise or run, sir?
Mm-hmm. What you say? What you say?
So I'm asking if that's the rise or is it the run? Right there.
This is a rise and this is a run.
But you label it wrong.
I don't finish fixing it up yet, man. I'm just trying to sort up. I'm copying and pasting to do the stuff. Thanks, though. I'm fixing up. I never thought about it when I was preparing the notes for you. But I'm a copy and paste guy. You will learn that if you have not already. But thanks, though. All right. That look good for now. All right, and then now this can come over somewhere, you know, because this can, we can tell them, say, this is for this piece out here, so rockstone. Yeah. All right, yeah. So now I'm gonna have my rise, and then I'm gonna have my run. Watch me. Y2 minus Y1 over X2 minus Y1 is the same thing here. Copy. Go over there, so paste. No, I want to come over a little bit more. It's the same thing as me having my rise over my run. All right? The same, you know, and M is always going to be the gradient. Yesterday, today, and tomorrow. Yesterday, today, and tomorrow. M is always the gradient. M is always the gradient. All right? Gradient slash slope. Gradient slash slope. When you find dy by dx, you're finding the gradient, you're finding the slope. All right. Now, it's going to be y2 minus y1 over x2 minus x1. I'm not going to spend the whole time or Rockstone time finish, but give me a few minutes, please, guys. I just want to finish this piece here so that you can see it. This is a difficulty now with online teaching. In order for you to see y2 minus y1, this is y2. I have to make my things very clear so that you guys can see what is happening. Y2, x2. X2 is going to be x2. All right, I'll just do one of them and hopefully I finish up the next. All right, so here I have my x2 and my y2. So my bigger y value is going to be my y2. My smaller y value is my y1. So up here, so see it here, so where the orange and the green line meet, it corresponds to 3 on the y-axis. So 3 is going to be my y2. See it here? Y2 is 3 minus my y1. My y1 is going to be -1. All right, so it's going to be 3 minus 1 over my x2, which is 2, minus 0. Because 3 minus 1 is 4, and 2 minus 0 is 2. So I'm going to have 4 over 2. So the gradient is 2. The gradient is 2. The gradient is 2. Now, I say to you the algebraic method, and this is where I'm going to end. The algebraic method, later on, we'll look back at this approach. I'm going to look back at this approach, but I'm going to show you. I'm going to find the gradient. See, I repeat the question, given f of x is equal to x squared, we need to find the gradient at the point 1, 1. I am going to what we call differentiate the function. I'm going to end up with 2x. I'm not even showing you how I get the 2x because I don't reach it. I'm just telling that it's 2x. I'm going to get my 2x. And where x is 1, see here, x is 1, y is 1. X is 1, y is 1. So where x is 1, 2 times 1 is 2. This 2 is the same as this 2 here. So suggesting and proving my point that when I use my y2 minus y1 over x2 minus x1, I'm actually differentiating because this is what I'm doing right here. I'm differentiating here. So what they want you to do or want us to do as teachers is to relate the derivative of a function with the gradient at the point of that function. So I can use what it is that you use in little school about finding the gradient of a line to finding the gradient here. And then come Monday, all being well, I'm going to maybe give you this other question. And then I'm going to jump into the notation for differentiation, right? Talking about y is x to the n dy by dx. And we're going to be moving into the different rules, the chain rule, the product rule, the quotient rule. All right. So this is where I'll end. But I'll ask you, are there any questions? I know this graph kind of looks a little crowded, but it's to bring across the explanation. Are there any questions?
No, sir.
No, sir.
Understand what I'm trying to bring across, right?
Yes, sir.
Yes,
All right,
sir.
good. So please, guys, remember I spoke to you about just listen out on Monday. By Monday, I should have some words for you as it relates to our SBA. And when I put you guys in groups, you see, remember we don't have enough time. So I'm just going to ask that each person just pull your weight. When you have your division of labor and somebody's supposed to write the introduction, and yes, please. And somebody's supposed to do something else, and somebody's supposed to do something else. You do what you're required to do so that we can produce this SBA in the shortest possible time for us to mark. We're going to be grouping you guys because we're not going to have the time to sit down and mark 33, I think, is a total number of integrated math students. I have the larger of the two groups, right? We're not going to have the time, so we have to group you guys. You will benefit from it because we are going to be teaching and going through the stuff. No, I don't want people to put themselves in the group. You know why? People going to want to put themselves with them friends. But in this case, what I want to happen is I want each person to be responsible so that we can work one with another and help people. I know you can say, sir, I want to go into the group with Mrs. Henningham, right? Because Mrs. Henningham bright. No, we are going to be grouping, because one of the things I should tell you, finally, one of the things I should tell you is that, so you may be in a group with somebody from the day integrated math class, because both groups are going to be coming together and we're going to be randomizing the students for the stuff. So you may be in a group with somebody from the day group, and it may be a first year student. But nonetheless, you know, when the papers come in and the groups come in, Mr. Russell and myself will be marking those SBA. So I'll be marking SBA with students who are in his group, and he will mark SBA with students in my group. So we mix it up, all right? And so we can learn from each other in this regard. You don't have to worry about it. We are going to be doing the stuff together. I'm going to teach you the topic. Oh, Rockstone, I need to do regression and correlation on Monday with you then. All right, so I may take a pause with this for Monday. I'll sort of my headspace. I may take a pause, so it is that we can go through, I can go through the topic with you, and then yeah, I'll sort of my headspace. But yes, so come Monday, you should hear more about the SBA. On tomorrow morning early, I'll send you a link for those of you who can join my business calculus group. I'll be going through, I'm sure I'll be going through some more piecewise functions with them. I will be doing some differentiation with them tomorrow, but they are not required to know this piece. They are required to know, this is not their notes, so their notes are going to be different, but you will see this because I think I did the same thing for them. So you will see from 2.2 onwards. So if you come to class tomorrow, you will have a jump start for when it is that we move through, for when it is that we move through our differentiation. It would be nice if you could come to class tomorrow. I'm inviting you. All right. I've taken 8 minutes of your time. Are there any questions? Yes, no? All right. If not, I thank you for coming out. I'm going to answer to you, not because it's nighttime, it means that you're going to sleep. We don't have sleep time again. I'm going to answer to spend some time to just reflect on what it is that we did and do some serious work. Thank you for coming out. Remember to say your dream to Jesus. Have a good night, a very, very good night.
Bye, sir. Same to you.